roughly.
Okay, again, as you see, there are lots of problems. And for those of you guys who can flip down to the bottom, guess what? There's all the answers. All right, just in case. All right, just in case. All right, so here we go. Okay, the first set of problems here. The first set of problems are just really factoring once, and it's factoring out the GCF. So step number one is always to see if there's something common. Maxine? All right. Now, in question number one, what is common? 3. So you should be able to say 3 parentheses. Thank you. 2x plus 1. Now's the time you speak up. Connor, you with me on this? Michael, you guys that have been sick. Question number 2, somebody, well, I'm just going to go down the left side. Is everybody with me? I'm going to go down the left. And then tonight you can do the right. All right? So what are we factoring out in number 2? 2x is good, but 8x is better. Right? 4 is good too. 8x is the best. Now here's where people make mistakes. It is 3x minus what? 1. Remember, you're dividing numbers. Maxine? Right. Listen, Maxine. I'm not giving you a hard time. You know that, right? I'm trying to make sure you're caught up. That's what I'm asking. Okay? So if you're not understanding, Maxine, you know I can't help you, right? So you're good. Okay. Michael, Connor, you guys good back there? Now I mean it. Drew? Oh, okay, okay. Sorry. Number 3, what do we got? 6.
X minus 12. Or 2, sorry.
6 times quantity x minus 2. Yes, ma'am.
What if we put 3? How would we, I know
You'd be
we have to
wrong.
simplify that.
You'd be wrong. The reason you'd be wrong is because, listen, you're looking for the largest number that goes into 6 and 12. 3 is a common factor. It's not the greatest common factor. You're looking for the greatest common factor. All right? So now, 2x squared plus 8x. What's common?
2x.
2x. What's left behind?
X plus 4.
X plus 4.
3.
All right? Number 5. What's common?
2.
What's left?
2x plus 5.
Number 6. What's common?
5x.
What's left behind?
2x plus 7. Woo,
All right, number 7. What's common?
5xy.
All right, here we go. Now this is a little bit trickier now. 5xy. Divide numbers, subtract exponents. So we're left with
2x minus 3y.
good. All right, so if you're in pretty good shape on 1 through 7, that means you understand how to factor out a GCF. That should always be step number 1. Miss Quigley.
I'm confused on 7.
Okay, so remember, what I tell you is, I used to tell kids, this is like a bucket. All right? If I pull an X out of the bucket, how many X's are left?
Oh, 1.
Right? And if I pull a Y out, there are what? None left. You with me on that now? Shh. Look, boys, I am in the middle of explaining something. Somebody asked me for help. I'm not going to be interrupted. All right, you have so many problems to do. If you're good, just keep right on going.
Oh, yeah.
You sure? I don't want you to think you got it.
I mean, but like, why do you take out
Because we're factoring.
Oh.
We're undoing the multiplication is kind of what we're doing. All right, now, the one thing I want to show you too is everybody look up. If you're unsure whether or not you got the right answer, you can just remultiply things. this times this, and this times this, and then you will get that right there. All right, is everybody with me on that? All right. Now, difference of squares. Now, literally, this should take seconds. All right. At this stage of the game, you ought to be able to say, number one is what?
X plus 1,
X plus 1, X minus 1.
Oh, that.
Number two should be
X plus 3, X minus 3.
X plus 3, X minus 3. Now, the boys have been sick. Any questions so far? Anybody have any questions? Now, number 3, we would say is definitely what?
X plus 2.
Wrong.
Prime.
Prime. All right? You cannot factor when it's a plus because there's no way to get 0 for a middle term. So understand me. One sign has to be plus, one has to be minus. If one has to be plus and one has to be minus, it would have to make a negative. Now you're with me. All right? So 3 is prime. Okay, so now 4 is
X plus 5, X minus 5.
good. X plus 5, X minus 5. Number 5.
3y minus 4, 3y plus 4.
Good job. That's how quick it should be. Number 6. 2x plus 5, 2x minus 5. Number 7. Wow, is that Drew back there? Wow, he did kind of tell me it was easy. All right, Drew. Number 8. Let's see how smart you are. Oh, is not an answer.
I did a minus x, a plus x.
Wow. All right, now if you just leave out,
Yeah.
we'd be good. All right. When you multiply a times a, it's a squared, right? When you multiply x times x, right? Okay, number 9. They're trying to confuse you, Bella. What do we got for number 9? Shh. Is not an answer.
Sorry.
That is not an answer either.
Okay. One.
I'm on number 9.
Well, it's gonna be minus 5 and plus 5.
No, it's going to be 5 plus m and 5 minus m. All right? Now, generally, we do say to put the variable first, but it's harder to factor when it's a negative m squared. Take my word for it. All right, leave it like that. All right, leave it like that. All right, Tara, you're up. 10. X minus 4y, x plus 4y. And number 11.
5m minus n, 5m plus.
Okay, now I'm just going to look over on the other side to see if I have to factor anything out. So on number 12, listen to me. Change 12 to 16 minus x squared. All right, it's easier to factor it that way. All right, number 14, there is a GCF. So let's take a look at that. Everybody, I have to factor out a what first?
2.
You have to factor out a 2 first. I'm asking you to jump to number 14. Factor out a 2 first. When I do that, that becomes 2 times x squared minus 4, right? And then 2 parentheses x plus 2 times x minus 2. Okay, thank you, Maxine. What?
What is it?
Greatest common factor. That's what we did in these problems up here. That's what that was called. GCF. Greatest common factor.
How do you know?
Well, you have to, listen to me. Every year, that's the biggest question. How do I know? I'm never going to remember all that. Step 1, look for a GCF. That is always step 1.
I mean, what's it the rest?
Step 1, look for a GCF. That's just it. That's the rule. Every single time you look for a GCF in every single problem. Sometimes there is, sometimes there isn't. Yes.
Like, why wouldn't it be like 16 GCF?
Shh. Which one are you doing?
16 below. Like number 16.
Okay, so is there anything common with 4 and 81?
Oh, so it's like the first time you can find it.
Yes, that's what we're doing. That's what that means. It's got to be common to both. Good, Hayes.
So it would be one on 20?
Yes, sir. Good job. Very good. You would factor out a what? 5. So let's just do 20. 5 parentheses x squared minus 9y squared. So then that becomes 5 parentheses x plus 3y times x minus 3y. Good.
What would you do like about 16? How would you
16. Well, how do I make 4a squared?
a 2a and then 2a.
And how do I make 81b squared?
9b
And 1 is,
positive.
yeah, Maxine, that's what I'm saying. That's honestly how simple it is. What?
Okay, so when something's like prime, does that just mean like?
That's the answer. 14 is what? Or 15 is what? Prime.
Positive.
Yes.
But like, how do you know like if it's prime? Like if you can't because that's a
You
positive.
can't factor it.
So if you can't factor like
It's prime.
any number, it's just prime.
Prime, yes. What?
I don't understand number 9.
Because first you should write it as 2x squared minus 98. Then you factor out a 2. It becomes x squared minus 49. And then that's 2x plus 7, x minus 7. What's the matter with that?
Sorry, I see it.
What?
How do you know when you have to?
No, I want to know what problem we're working on.
Okay, well, I just don't understand for these, like, why this, like, the guessing check ones where it could be like 9 and 1 or 3 and 2.
Because these are specific type of problem. This is the difference of squares. This only applies to this. How can I recognize difference of squares? One is there's a subtraction, and the other one is how many terms are there? 2. All the other ones have 3 terms. And then you can recognize factoring by grouping because it'll have what? 4 terms. What?
Oh, how you got the
Come on, Hayes.
4 that equal?
Which number?
2x squared minus 98 on 19.
What's the matter?
So I'm just
I just rewrote this.
oh. But why did you?
Well, because I want the variable to be positive. I want it to be in front.
Okay.
Everything else has it's positive first and negative second.
Okay.
What?
Why would a 19 be
Because 98 is divisible.
Because 98 is negative. Switch it.
Number 21.
Yeah.
Oh, come on. 3x squared plus 2. 3x squared minus 2. Come on, guys. What?
Why is it like? Why have to do all that stuff? Why can't you just do like for number 20 instead? Like, why do you have to write the 5?
Well, what do you want me to tell you? Because that's how you do the problem. How do you want to do it?
Why can't you just do it like the one before? Because that one.
How? What times what is 5?
9.
Is 5 a perfect square? 9 times 9 is 5. That's pretty good.
I mean, 5 times 1 is 5.
5 is not a perfect square. 5 is not a perfect square. You can't have 5 and 5. 5 times 5 is 25. What?
Alright, so I'm confused on like how you did 21. If you just look at it, you think it'd be prime, and then you put it into these parentheses and did it. You could do the same thing for 15 if you said it's prime.
Because it's plus.
There's no negative.
There's no negative.
Maybe 13.
What times what is 36, Maxine?
6.
And what times what's 121?
Oh, I have many parts. I'm sorry.
All right, here we go. Next page. All right, now again, these are considered the perfect squares. Now, I don't even expect you to remember that or know that, but I expect you to just be able to say, look, we're just factoring. So this is x and x, factors of 16 that make 8. Positive 4, positive 4. For those of you guys who want to be really smart, you would just write it as x plus 4 squared. All right. Number 2, factoring that. X minus 8 equals x minus 8 squared. Connor Drinkard, are you with me on this? Drew, you still telling me things are easy?
Yeah.
Hayes, where are you at? And Maxine? All right. So, because we spent so much time, I'm going to jump down to number 5 now. All right. Again, how do I recognize these are perfect squares? Because the first and last are both what? Perfect squares. So this one will be 4y plus 1, 4y plus 1, which is 4y plus 1 squared. Everybody happy with that? Number 11. We should be able to say that's 5a plus 6 squared. Start seeing the pattern. Now, it's not really necessary to switch 12 around because you recognize they're squares, but it would be 4 plus 5x squared. Everybody okay with that? Number 15. Someone read me 15. What do you think the answer is to 15? Maxine.
5.
Which one are you doing? Tell me.
15. 5 plus, no, 5 minus,
Come on.
5 plus 3y squared.
Okay, now first of all, you're not that far off, so come on. First of all, the 9y squared is first. So you would put 3y first. Then you would put 5 second.
Oh, and then
Now it's negative because,
it's negative 30.
okay. Allie, you with me? What?
Oh, wait.
What?
I'm doing 13.
What's wrong with that?
I don't know. I think I might have an error. Oh yeah, I did.
Okay, here we go. All right, here we go. It's kind of like they tried to make it a little bit harder by throwing in a couple extra variables. But let's just knock this out. Let's take a look at number 3. Let's look at number 3. What times what is 169? That's right. So it'd be 13m minus 2u and 13m plus 2u. Everybody okay with that? And then let's just look at number 4. Let's not be confused. Number 4, we could say that's what? xy, 3z squared, and a positive 3z squared. I don't think that's that bad now. Come on. And I'll do one fraction one. Number 6, yes. Let's look at number 6. All right, how do I make 1/9?
0.9.
1/9.
Oh, wait, no, it's,
Come on, what times what is 1/9?
1/3.
1/3. How do you not know that? They're perfect squares. 1/3 times 1/3 is what? 1/9. Come on, you should know that. 1/3 x minus 4. 1/3 x what? Plus 4. Number 8, they're trying to get real crazy. What would that be? Y cubed minus 10 and y cubed plus 10. Beautiful. All right. Now 9 looks hard just because you see a fraction again. What times what is 4/9? 2/3. So number 9, it would be 2/3 xy minus 5/6z. 2/3 xy plus 5/6z. Yeah, it's not. It's not hard at all. All right, so let's scroll down to the next one. All right, now these are back to really easy because the leading coefficient is a what? A 1.
Oh.
There is no GCF. All you're doing is factoring. So everybody should be able to look at number 1 real quick and tell me that is
X plus 4,
x plus 4, x plus 2. Because 4 times 2 is 8. And again, you're looking at the smiley face.
Oh.
All right, number 2 would be what? C plus 2, C plus 3. Number 3, y minus 7, y minus 2. Connor, you still good? Hayes, you still good?
Wait, how'd you get 2? I forgot how to do this.
Remember now, the smiley faces. -7 and -2 makes that -9. Do you agree?
Oh, yeah.
And then y times y is y squared. -7 times -2 is positive 14. You happy with that? Michael?
Yeah.
Number 4, what's the answer to number 4 then?
X minus 8.
X minus 8, x minus 2. Let's jump to number 7. Factors of 36 that are 15. Can you tell me the factors of 36?
4, 9, 6.
Oh,
wait,
That'd
no.
be 13. What?
13 and 2.
13 and
2. 3.
say it again.
3 and 12.
3 and 12.
Oh, wow.
So x minus 3 and x minus 12. Does everybody see that now? All right, what are the factors of 54 that make 21? 6 and 9 makes 15. 8 and 7 today is 56. 2 and 27.
21 and 2. No.
21.
2 and 27 does not work. What else?
20. Don't yell at Miriam. Oh,
9 and
No.
22.
22. Yes.
22 and 2. 20.
So if it's divisible by 6, it must also be divisible by.
27.
Say it again. Loud and proud. Good job.
Dang it. I said 19 and 2. I was so close.
Yeah, 19 times 2 is so close to 54.
What's 19 times 2?
She answered herself.
All right. Go down to the next slide. All right. So listen, continue down. Do as many of the problems on the left.
Right.
Most-
Right.
Which ones am I doing?
Remember you said
I'm
left.
going on the left. Tomorrow I will do the ones on the.
Right.
For those of you guys who just want to make an A, do as much as you can. Do the left and right. Some of you guys are just doing it for fun, so I appreciate that.
Mr. Stroud.
No one does that. Easiest math we've ever done. I'm so happy with this.
Mr. Stroud.
Like the other stuff was